Hi everyone, welcome to this new tutorial. Today we will be building a Zelda-like game using JavaScript and also the Kaboom.js library. So Kaboom.js is, I think, the most intuitive library for making games. Now it's not perfect, but yeah, I've been making a lot of tutorials on it recently. Now the game today we're going to build is a Zelda-like, and we're going to do it a bit differently from what you're used to if you're familiar with the channel. And if you're new, you're also welcomed. I'm going to go over all the concepts you need. The only prerequisite you need to have is some fundamental level of JavaScript. So at least the basics of JavaScript. All right. So in this game, we're going to build this Zelda-like. But unlike the previous tutorials where I would draw the map layout using an arrays of string, so multiple arrays of string, which would become quite tedious, and this is the current way supported by Kaboom. In this tutorial, will be using Tiled, which is an editor for making your levels that is graphical. So it's much easier to just take a tile and put it on the layout and then export that into a JSON file that you will then load in Kaboom.js. Now, it isn't known how to do this, so it's exclusive information that I've discovered, I guess. So stay tuned, I guess. Now, before we go on, I just want to showcase like the actual project we're going to build. So it's, like I said, it's a Zelda-like. Initially, you start here. You don't have a sword at all. You can already see some slimes walking around. Now I can enter a house. So this is going to be basically our second scene, and you can talk to the old man. And what you'll notice is that we have a dialogue system going on here. And I'm going to show you how to implement this. And also when you come back, he says different things. And then if you go back again, different things. And then it will start over from the second line instead of the first, where he give you the sword. Now also, if you've been reading the text here, basically he's saying that he's going to give you a sword. And now you have it, so you can use it. Now we can start our adventure. So the whole goal of the adventure is just to go save his son that is trapped in a dungeon. So here you'll see that I can hit enemies like that. And at the top left corner, you can see that my heart, I lost half of it. So you're going to learn how to build this as well, how to manage health for your player and how to display it, update the UI for it. If I go inside the dungeon, this is basically our second scene, and this is the son that is trapped. If I go here, he's going to tell me to help him, and he's held prisoner, and that the keys are held by a ghost in the next room. And this ghost is going to basically be the boss. And now this is just a nice transition that looks like older Zelda games. I wanted to include that to show you how to do it. Now let's try to fight this boss. So to fight this boss, basically he follows you everywhere. So he has two phases. When he dashes towards you, and when he moves back after you start attacking him. So he's slightly smart. Now I only have one heart, so I have to whoops, I think I died. All right, let me defeat him, because after that you're going to see how we're going to keep game state, so that the old man knows that you saved his son, and yeah, so that the game can progress and you can finish the game. Now I'm just going to put myself here. Come on. I need to hit the keyboard a lot. I don't think I'm gonna win. Okay. Third times, I guess. Now I have coded it in such a way that I should be able to beat him if I put myself here and just spam. Let's see if it actually works. Now this isn't good game design wise, but yeah, you can modify, of course, the code base to make sure that the player cannot game the system like that. Okay, as you have just seen, the ghost has left a key. So I can go here, come back, and then the dialogue will change and the door to the prison will open. Oh, wow, you got the keys. Thanks for saving me. And then I enter here. I talk to him again. Thanks again for saving me. Go talk to my father. He will reward you handsomely. All right, so now that we go back to, so just to make sure that the state is properly kept up, you can see that the ghost does not respawn. All right, so now let's go back to the father, the old man, and tell him that, hey, we saved your son. And here we go. and you'll see, as a reward for saving my son, you can keep the sword I gave you. So this is basically the reward. Now, I made the code base in such a way that you could feel free to expand it in any way you want to make, like, let's say, give to the player a shield, for example. Now, just before we continue on, I just want to tell you where to get the assets. So first of all, the assets I've took for this is this. So it's made by someone called Moomin, and I just wanted to shout him out. It's a free asset pack, but we're not going to use it exactly as it is. I made some modifications, as you may have noticed. I have like used brighter colors and added some tiles. So in the description of the video, you'll see everything, the link to the assets you actually need to download, but you'll also have a link to the original asset pack from which this one I'm currently using is based. So feel free to give him a download just to support his work, I guess. All right, so now let's get right into the code. So right before that, if you haven't done already, I'm just going to go in the development setup. So let's start with the development setup right now. So first, download this tile software. For now, just download it, install it, and then we'll see. The link should be also in the description, and then I'll go over how to use the program later down the road. Now, the other thing we need is to set up our dev environment. So I'm going to open my editor. So here is an empty VS Code window with a empty folder called Zelda game. Feel free to name it however you'd like. I just want to say that if you don't have VS Code installed, I really recommend it because it's really how I develop things. We're going to use a couple of extensions, basically two, that will make development very easy. So I really recommend that you basically just go with what I'm going to use here. So the extensions we need here is Prettier. Now the reason I want you to install this extension is that Prettier is a code formatter. What it will do is each time you save, it's going to reformat your code to look neat. And in the previous tutorial, I wasted a lot of time trying to format my code. And the reason I didn't install a code formatter is because I thought that it would add too much of a burden on the viewer to know, hey, how to install this thing. But I decided to just show it to you right from the get-go, so that, yeah. So install it. So go to the extension marketplace, type in Prettier, and then you should see an install button. Here it's written uninstalled because I have already installed it. Now it's not enough to do just that. You have to add this block here. So if you scroll down, you can see this thing. So this you're going to need to add it. So copy it first. I'm going to tell you in a moment where to add it. So first let's copy it. Now here in our folder. Now I think my code editor is set up to actually work with Prettier even from the get-go. So even if I type in main.js here and just write some console.log and then I simply hello, it reformats it. The reason it does this is because in my user settings, I have set up this as the default formatter. Now, I would like to go a different way. So the first way is where you just use Command P, type in settings.json, and then you can have your user settings where you have this part, editor format on save. This part is exactly the part we copied. So you can do that. You can feel free to do this. However, I prefer to just have a folder within my VS Code, my project called VS Code. And within that folder, you have a settings.json. And within this, here it's where I will paste this configuration. Now, we also need to set up how Prettier is going to format our code. Now, usually the defaults are pretty good, I think. I think the defaults are good, but maybe I have some preferences. If you have some preferences, I'm just going to show you. So to create a config file for Prettier, you simply need to create a .prettierrc.json file. So prettierrc.json. Within here, if you, for example, write semi, here you're specifying that you want semicolons to be removed. So for example, here, it's going to remove it as you save. Now, this is not what we want actually. I don't mind having semicolons, especially if it's done automatically for me. If it's not, then it's tedious. But for the tab width, this is something I would like to configure. Now it's set to 2 spaces. I want it to be 4. So now, for example, if I write a function. Now, by the way, if prettier doesn't work, so yeah, you see when I do a tab, so if I do console.log test, and then right below it, tab is going to take 4 space instead of 2. So this is what I prefer to use, and feel free to follow me or just to remain with 2. It doesn't matter that much, but otherwise, yeah, this is what I wanted to show. Now, it might not work automatically after having done this on a clean install of Prettier. What you need is you probably either need to reset, to reopen VS Code. So try that first. If it still doesn't work, what you can do is you write some code in the JS file, test, for example, and then you hover over, you select it, you right click, and then you do format document with, and then you should see Prettier as the code formatter. Once you click this, it should basically set up your code formatter as being Prettier by default. All right, so hope the first method worked, so that you just have the code Prettier working as soon as you reopen, you close VS Code and then you reopen it. But if it doesn't, feel free to, if it still doesn't work, please feel free to add a comment to the video. I'll try to look into it, or maybe someone else that watches the video could chime in as well. Okay, now let's set up another extension we need. The other extension you need for this project is live server. So basically, it starts a server in a local server within the folder you're currently working on. The reason this is useful is that to make games in JavaScript, you need to have a server. Now, there are many options. So if you're not using VS Code, you could start a local server using Python. There is a command for it. Look it up on Google. Otherwise, yeah, just follow me. And you can see at the bottom of the editor, at the bottom right, you can see a Go Live button. When you click on it, it starts the server. Now, for now, it's not useful. We're going to start this in a moment. All right, I can just close this, and let's set up the various assets we need, the various folder structures, etc. Now, main.js here is something that we're going to need, actually, so I'm going to keep it. Now, I'm going to create a folder. Well, actually, never mind. We're going to create first a folder. I'm going to call it source, which will contain basically our source code. Sorry. I'm going to drag and drop main within it, and let's keep it at that for now. The other folder we need is the lib folder. So the lib folder is going to contain a local copy of the Kaboom.js library. So usually now in JavaScript, you usually use a bundler, and you just write npm install the library you want to use. Now, I'm not assuming any level of knowledge in front-end development here. I might in future tutorials when I'm going to try making games in React, hopefully, where it will be necessary for me to use commands like these. But for this project, we can just use a JS file, MJS file, to load the library. Now, you have 2 ways of doing this. Either you use a script tag within your HTML. Now, this is good, but it could theoretically happen where the library is no longer available online, and that means your game will no longer work. So having a local copy and freezing the version, well, actually with a CDN you can freeze the version as well, but just having a local copy is very useful. So yeah, I'm just gonna drag and drop from my other window here the library here. So you can see that it's a bunch of squibbles, and here it's just a text file I put for myself just to keep track of which version I'm using in the tutorial. All right, so for this file, the link will be in the description. Basically, it's a link towards you click on that link, you see the code here in your browser, in the browser tab, you just right click and do save as MJS. Now, the reason we're using a .mjs file here, I think it should be important to explain it, is that in JavaScript, recently you can use modules. So the import from syntax that you're used to in maybe a Node.js environment wasn't available before, but now it is. It's not that new, but to use it, we need to have an MJS file. So I think it's best to just show it to you. So let's do just that. Right before doing that, I'm gonna hopefully not forget to come back to explain this further. So yeah, let's move on a bit. All right, I'm gonna create an index.html, which is basically the entry point of our program. Now, the HTML isn't really fancy. You just need an HTML tag, a body tag, and then put in the script here. So script type module, and then, so the reason we're using type module here is that to allow us to, in our main.js file, to use the import syntax, being able to do import from. The previous way, the older way of importing libraries would be to just have another script tag with the file towards that library. But this gets messy when you have too many imports, and you cannot like structure your own code very easily. So that's why it's best to use a module. So even if you want to import, make another file code available in another file, you would have to use this script notation and put it right above. And I did this in my earlier tutorials. So if you look at the Pokemon game making tutorial that I made earlier on, I used the script tag above like that, and it gets messy. It doesn't get that messy in the tutorial because the game I built was pretty small, but if we want to think, we need to always think a bit further than currently now, so as to avoid a lot of pain later down the line. All right, so now in the source folder, we're going to create a couple of folders here. Actually, before that, we need to create our assets folder at the root. So assets folder. So what the assets here are going to be, we're going to contain another folder which are going to contain our maps. Now the maps we're going to build are going to be built with the tiled editor, and tiled allows you to export your map as a JSON file, and this is where we're going to put the maps here. Now for the actual assets here, I'm going to put it right here. So top-down asset.png. You should find in the description a link toward that. It contains everything we're going to need for this game. So everything is compact into one single sprite sheet like you see here. So that's pretty good. And that's one of the reason I wanted to use this asset pack, because instead of having like multiple folders of images and you could miss one, this makes it very easy for you to follow along. Now we need a font, and as you've seen in the game, I use the Game Boy like font, and here again it's gb.ttf, so feel free to, in the description you should find a link towards that. All right, we have everything we need when it comes to asset. The maps, we're going to create them later and put them here. Okay, so we're ready to continue on. All right, so now what do we need? We need to actually go into our source folder and create a bunch of various folders. Now, one thing I forgot to mention here is the index.html. You have a source/main.js, the path, because we want this to be our entry point to the game. Now, yeah, so that's basically it. Here in the source folder, we're going to create a couple of folders. I'm going to create the content folder. Now, the reason I'm creating a content folder is I'm going to keep all the text content, so the dialogue and what's in the title, etc. By the way, there was a title in the game, a title screen. Sorry, I haven't shown it to you. So the Legend of JS, basically, it allows you to switch languages. I'm going to teach you how to support multiple languages. So here it's in French and here it's in English. Of course, maybe you don't know two languages, so maybe you can skip that part or try to put some Google translated stuff here. Now that's the menu, is bare bones. That's why I didn't want to show it to you in the beginning. But yeah, so that's that. Now, just to showcase again, if I refresh and go to the French version by pressing the F key, the character will talk in French. So that's pretty cool. Now, in French, normally there are accents. So here in the E, there's supposed to be an accent. But however, the Game Boy font does not have any accents available. So, and in French, it is allowed actually to write in capital without accents. So you would see that in France mostly, but if you go to like Canada, the French part of Canada, or French speaking part of Canada, then we usually also use capital, even in capital letters, we would use accents. Now, this is one of the pitfalls, I guess, of trying to do your UI in the canvas, is that you could have some issues with text in various different languages. Well, one thing that comes to mind is that if you want to support Arabic, it's going to be very complicated because in Arabic, the letters are joined sometimes and sometimes not. It depends on their placement. And by default, if you try to just display Arabic text, it's just going to display them unattached and it's going to be basically unreadable. It's going to be displayed in their unattached form, which can look very different than their attached form, which why it becomes harder to read. And this is where I think maybe in the future tutorial, where I'm going to start making games with React, we're going to see how to basically build a UI layer on top of the canvas by using actual text, actually the browser, because the browser are made to support probably all major languages. So we don't have to do that work again. So that's something for the future, hopefully. Now, okay, let's go back to the code base. Yep, so I'm just going to refresh here and reopen my editor. Now, okay, so we have a content folder. We'll keep it empty for now. At the same level, we're going to have an entities folder, which is where we're going to put all of our code that we need for various entities. So the player, the slimes, and the ghost, and the old man, which are the 4 entities we're going to need to code logic for. As for the sun, it's basically not needed. We just need a collider and to collide with it. So yeah. And then another, whoops, not here, within the source folder as well, we need another folder called the scenes folder, which is where we're going to store all of our scenes. And finally, a state folder where we're going to keep global state. So here I'm going to go over this later, but having this pattern is going to make our code very, very, very convenient, very maintainable, I guess, not convenient. All right. And finally, the UI components folder. So this basically is going to contain all the dialog text box and stuff. There aren't many. There's basically like 2 things, the health bar and the dialog box, which are the two components we need here. All right, so now let's we have our setup basically done, and now we want to display something on the screen. So let's get right into that. So in the source folder, I'm going to create another file. I'm going to call it Kaboom context. Now this is different. If you have followed my previous tutorial, we would usually just import Kaboom globally and use the functions like that. So they are globally available in any file you import Kaboom in. But this time around, we're going to create a context, basically a constant that you need to do k dot and then the name of the function. So that just by looking at the code, you'll know that this function comes from Kaboom. So that's something that's pretty handy, and it's going to make it easier for me to explain to you like what is from Kaboom and what is just normal JavaScript. All right, so in this Kaboom context file, what we're going to do is we're going to import Kaboom. And to do that, we just do import Kaboom. So now we can use the import syntax from, and then just so you know, like you could always use the import syntax here. It's not because we did anything special yet. It's just because in the index.html, we have the type module, which is basically allows you to use the import syntax within a main.js file, within the main.js file, which is the entry point. But even though we aren't in the main entry point here in Kaboom context.js, we can still use the import statement because afterwards we're going to export it and then use it within here. So basically, the system is smart enough to know where to look for, to know that this is actually a valid import statement, and it can pull, like, it can from the entry point know all the references to all the things you import using the normal import, the module import syntax style. Hope this was not convoluted. If it was, ignore everything. Just know that since you have used the type module here in the main.js, you can just use the import statement. All right. So we're going to import Kaboom from, and from where? From our library. So this is the path we're going to. So dot dot, basically, if you're not familiar, I want to take the time to explain this because I don't know your level, and I would rather not assume any like major previous knowledge, rather than just you copy this without no understanding. So dot dot, basically from this, so from the file system, the two dots allows you to go back a level. So if you see it as a tree, you have, I think a diagram would be in order here. So I'm just going to go excalidraw.com, or let's try a new one, tldraw. I think it's tldraw.com. All right, nice. All right, so here, if you're more advanced, this looks like a waste of time, but please bear with me or skip ahead. I just want to explain this just to make sure that everyone is on the same page. So we have so we have a bunch of folders. So that's the root. The root is, where's the text? All right. So we have our root, which is the slash, basically slash. And in this slash, we have various folders. We have the source folder. I'm wondering why it's doing something like that. Okay. This is much better. We have the source folder. Maybe lower this, make it smaller. So we have the slash, and then it's gonna make sense in a moment. We have another arrow, another arrow. Let's just keep it at 3 and imagine that the rest is also defined. So here we had our libs folder. The font looks nice. It's the first time I actually use tldraw to explain stuff. So this is the rest. And now to understand, let's draw the actual path. So slash search slash libs, so you understand why I put a slash here. Now here, within this, we have our Kaboom context.js file. So Kaboom context.js. And this, the path for it, so we don't just, it's slash source slash Kaboom context. So for you to import something from the libs folder, because in the libs folder, you have slash libs. I think it's lib, not libs. The name, yeah, I called it lib because there's only one library. So sorry about that. So lib. So here it's going to be lib slash and then kaboom.mjs. So the MJS extension allows you to import it as a module by using the import kaboom from this. So yeah, this is why it's an MJS and not just a normal JS file. So now if I want in my Kaboom context.js where I'm writing the import statement, I'm writing import Kaboom from, I need to specify the path where this file needs to look for this. And by doing ... you're basically telling your file system, well, actually, I don't know who you're telling, the interpreter, I guess, the JavaScript interpreter, to go back one level. So levels are here. So this is a level. This is another level. And finally, I really like tldraw. I just realized it's it's even better than excalidraw. It's very easy to use. All right. We have 3 levels in our file system. So by using ... you're telling their JavaScript interpreter, I guess, to go one level below, I guess. So one level behind. and then to go to the libs folder by using /lib. So it's going to go here, 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 and then Kaboom.mjs. Hope the explanation was Hope the explanation was clear and what this two dot means. If you haven't had any like formal computer science education, this might seem like you might not have known this. So hope it clarified things for those who are more beginners. And yeah, let's continue. All right, so let's jump right into, so I'm just going to write the whole thing. So lib/kaboom.mjs. I save it. Now I'm going to create a constant. I'm going to just call it k, just so that it won't become too tedious later on. So in Kaboom, to create the canvas, you need to call this Kaboom function. So you call Kaboom and you pass in an object. It takes a few params. We're going to first pass it a width of 1280 and a height of 720. So this is just a standard 6:9 resolution. Now we're also going to need to set the letterbox property to true. The reason you need this is so that your game canvas is going to scale regardless of the screen sizes of the user, the player, automatically, so you don't have to do any work. And finally, we're going to set global to being false. But by default, by default global is true, that means that once you write this statement, you can use all the functions of Kaboom by just calling them their name. But by using global false, you're going to have to do k dot the name of the function. For example, add, which is one of the functions Kaboom offers. Now we're just going to export default k here. Now, again, if you're not familiar, export default means basically it's the only thing that is going to be exported from this file. If you want to export multiple things, you just remove the default, and the import syntax is going to be different. So the from the other file. So for example, if I just do export k, declaration was I think it's export. If you just do export k here, when you're going to be in main.js where you want to import this, so I'm going to go here, go to main.js. I'm just going to do import and then use brackets because you can have multiple things to import. You can have k, you can decide to export another constant, another function, etc. And use the brackets here. But because we want a default export, we just want to do import k from the Kaboom context. And this is important here, is that you have to add a .js. If you were using a bundler, that would not be necessary, but because we are using JavaScript modules that is native to JavaScript, that is supported, ran in the browser, we need to use the .js extension here, as the browser needs to know that, hey, this is a JavaScript module. So if you were using a tool like Vite, and where your development workflow is basically you do npm install and then npm run dev, you do not need this, because anyway your tool is going to compile all of your code into a single .js file that you can just deploy somewhere. Now there are advantages to this approach, and probably if I make a React tutorial where I make a game, let's say an RPG, stuff like that, it's going to, we're basically required to use a tool, a bundler like that, because you cannot use the syntax called JSX with normal JavaScript. So basically having HTML elements within your JavaScript that aren't strings, that aren't within strings. All right, this is a bit like out of the topic for this tutorial, but I like to add stuff like that just so I believe in just-in-time learning, where you learn everything you need when you need it. So you can go into these branches of, so for example, I want to make a game. I don't know JavaScript. Okay, I learn JavaScript. Okay, I need to import a module. Okay, I need to learn how the path, this file system works, etc. And this might be slow at first, but you get a better understanding. Okay, so now let's go back to Kaboom context.js and remove this, the export. We want to export it default. So one thing that is weird is in JavaScript, you cannot do that. It's considered ambiguous for some reason. Now because you can have multiple const defined in a single line. You could have const b 10 or something like that on a single line. Now I know this isn't on a single line, but it's considered as a single expression, so that's why it's not allowed, I think. But don't quote me on that. Make your own research. I'm pretty sure it's this. This is the reason, but you know, like just I don't want to risk being wrong, I guess. All right, so I'm gonna do export default k. Now you can do this. Now here in main, you can have your k here available. All right, so we have our canvas, we have exported it. Now, I think we need to start our server. I think we just need to start our server. All right, so I have this. Okay, so this, don't forget to hit save frequently on the files. Otherwise, you might look at the output and not realize that you haven't saved. That's why nothing is happening. All right, you see there's this go live button at the bottom corner if you have installed live server correctly. Click on that and it's going to open a tab. And here you can see that just by importing K from Kaboom context, we have this beautiful checkered board canvas. So that means everything is working and we can really start diving in and work on the game. So let's go back into our editor. All right, so now what are we going to do is let's start with creating our various scenes. Now, a way to do that is to simply use the scene function that comes with Kaboom. So so for all the functions that I'm going to mention here, I'm always going to try to mention what comes from Kaboom and what is from normal JavaScript so that you have a better understanding of how you would use Kaboom.js outside of this tutorial. So what I'm going to do now is I'm going to create a constant, an object basically, but defined as a constant. I'm going to call it scenes. And it's basically going to contain the scenes we're going to use. Now this might not make much sense, so let's keep it empty for now. Right below that, I'm going to have a for loop. I'm specifically going to use the for in loop. So for in JavaScript is not the same as for in Python. It will not iterate through an array. It will iterate through a object and give you the key for that object, for each of the entry in that object. So here I'm going to have a const scene name in scenes. Now within that, this is where we're going to call our first Kaboom scene function. I'm going to call the k.scene function. This is a Kaboom function that allows you to define a scene. It takes two params. The first is the name. It's a string. Now, because we have the key that we want to pass here, we're just going to need to have the scene name here. Now, I may have lost you. So in the scene object, let's add a name, a string. I'm going to call it world, and it's going to point towards an empty arrow function. All right, so you see Prettier removes the quotation marks because in JavaScript, you can have objects without being like strings if there are just a single word without spaces. Otherwise, if I wanted to have world dot space like that, then it would remain as a string. Just something I thought would be important to mention. But basically, if you know your stuff already, I might sound redundant, so sorry. Now what we're going to do is that this scene function in Kaboom.js takes the name of the scene you want to create. So this is basically you're telling Kaboom that create this scene where the scene name is what I pass as a first param, so that when I'm going to refer to it later on, it knows that, hey, this is the scene you want to call. And the second param is a function. What this function does, it basically just, it contains the logic of your scene. Now what we're going to do is we're just going to defer to what's in the object, the scene's object. So I'm just going to call my scene object here, and then pass in the scene name, which is the key, and even call the function that is resulting. So we define the function here. By the way, you could even do this. In JavaScript, this is allowed to just have your function defined with an object. Now you're going to see in an instant that we're not going to put all of our scene logic here. We're going to put it in our separate scenes folder. This so it is more maintainable. So we have k.scene scenes. Here we call the scene within that. This might sound pointless for now, but what I want to do is pass the context here. So what I want is to only have one place, one source of truth where I call all Kaboom functions. And well, all because the k object basically controls the rendering. So by passing the k, I don't have to import k from Kaboom context in all of the various files we're going to write later on. So we just do it once, and most of it is passed through params like these. So I can add it here. Now, if we were using TypeScript, it would be much more straightforward what this does, because in TypeScript you have type information, like it will tell you that this is the Kaboom context. You would type it as it, of course. So yes, don't hesitate to try using TypeScript with Kaboom. It is supported. Now the setup for it is going to be very different than what I'm currently having here. The reason I do JavaScript game dev tutorials instead of TypeScript game dev tutorials I thought to myself that if you know TypeScript, you're just going to use it even when you follow my tutorial. So those who don't know TypeScript, it's going to be more accessible to them to just use JavaScript. So even if you're more experienced, you can still follow the tutorial because you're going to be able to adapt the code to your needs anyway. All right, so I have case scene, etc. We call it. Now we do nothing with it, and that's why it's grayed out a bit. And now finally, the last piece of code you need is you need to call k.go, which tells Kaboom which scene to go to, and you need this by default. You need to have a default scene. So that's why you need to call k.go in your main.js file most of the time if you're using scenes, because you could make a game with just the default canvas and no need any scenes, but that would be a pretty simple games. And I'm trying to progressively increase the scope of the tutorials, the games we're making. So yeah. All right, so here you just write as the string. So it takes one param. Actually, it can take two, I think. It can take a param and then values if you want to pass data to other scenes. But I preferred to go with another approach to state that is much more convenient than this. I tried using this in previous tutorials, and I think on a larger scale game, it would get messy. So that's why I prefer using singletons that control the states of the game, and multiple, not a single source of truth, which will become really big. So I usually have a game state singleton. I'm going to explain what a singleton is when we're going to do it, if you don't know. And this is from where we update and basically keep track of the general state of the game. Now we have specific state like player state, old man state, etc. All right, so here we're going to just put the default scene to being the world for now. Later on, we're going to create this simple menu scene to switch between languages. So that's going to be useful. All right, so we have this, we have everything. I think it's time that we just create our first scene from the scene folder, in the scene folder. So I'm going to create a new file within the scenes folder. I'm going to call it world.js. Now here, I prefer to use a default export for those things. I just want to export the scene and nothing else from this file. But you're going to see that later on we're going to use, I think the name for it is named export, or the other variants where you use brackets, when you can export multiple things outside of from a single file. All right, so I'm gonna write export default. Maybe I should increase. It's a bit too late for this, but maybe let's increase the font a bit. I think this is too big. Could be too big. Maybe. Okay, let's write our code with this font size for now. All right, so I'm gonna create an async function Now, the reason this is a sync is there a reason for this? Yeah, because we're gonna load the map from our JSON file within those scenes, and because of that, you need to have a sync await for this to work. All right, so I'm gonna do a sync function world and then pass in the k. So basically the same thing we did in our main.file, but we just keep it at that for now. And here, I'm just going to import, not on abort, sorry, import world from world.js. Remember, if your editor did not add .js, you need to do this. Otherwise, the error you're going to have is going to be a MIME type error not supported, or a MIME type, something MIME type, an error that mentions MIME type, basically. So now we don't need this. We can just call world like that. This might seem strange if you're not used to this syntax. This is a shorthand for having a key called world that pass in a function called world. If you save this, it's going to do world, but even more concise. JavaScript allows you to have simply world. All right, so I think we can look at the output. Nothing has particularly changed, and that's normal. Now to really make sure that everything works all right, let's go back to our world.js code, and within, I'm just gonna draw something on the screen just to show you. So I'm just gonna do maybe k dot. So in Kaboom.js, use the add function to add game objects, to create game objects using components, which are functions that you call within that array. And then so it's an array of component that you pass in to the add function, which takes care of creating that game object. And most of the time, a game object is visible. It's something that a sprite, for example. Now we're just going to use the rect component primitive that is available in Kaboom.js. I'm going to want a rectangle of 100 by 100 pixels, and I want to have its position. So you use the positional component, pos, and specify the x and y value. Now, if I want my rectangle to be at the center, I'm just going to use k-center component within the positional component. So this takes a vector2. Vector2 are just a pair of two values, x and y, but put in a neat data structure that is offered by Kaboom. So it's the vect2. You can either pass vec2 like that and specify 100 by 100, which is the x coordinate and y coordinate, or you could just have 100 and 100. So you have those two options, or you can use this specific component that gives you the exact coordinates for this center. So this k.center gives you a vector2 that has the x value corresponding to the center of the screen and the y value for it as well. So the coordinates for it. Now this, let's jump. Yeah, let's save this. And let's look at our editor. You can see we have a white square by default. Now, if you hit F1, you can see debug mode, which gives you the FPS, but also will allow you to see the hitboxes. Now here, you can see that the the rectangle is drawn from the top left corner. So this point actually is the coordinate. Now you can actually have it from, have the square drawn from the center, but you need to add the, first you need to add the area component, basically creates a hitbox for your rectangle. And then finally, you need to add the anchor component. And in this anchor component, you simply pass in the string center to tell Kaboom that, hey, you want this rectangle to be drawn from the center. So you can see that now it is centered. And if I hit F1, not only you have the hitbox now that is drawn, because we added the area component, which creates a hitbox automatically for you. And we have the point, the coordinate, which is the exact center of the screen. All right, I think we have everything set up, and we can actually start working on our players. Maybe let's start with the map first. So we're gonna use tiled. So here you can see that I have house, dungeon, world.js. Those are already done maps, but I figured that you wouldn't learn like that if I were to just give you the map. We need to actually create one at least. So my plan is maybe we create one together, like the world map. We recreate it, we display it on the screen so you understand, and then maybe you could use these already made from the GitHub repo, so you don't have to like it's not tedious. And by the way, those JSON files are not only the exported maps, but also the map that you can open within tiled. So it's the same format. All right, so in the next part of this tutorial, I'm going to explain how to use tiled to draw this first world.json map, and then we'll decide if we do this as well together, or I just give you the map already well done. I'm going to decide this later on, which one is better for your learning. I think that if you know how to do this, how I built this map, how I build the collisions, etc., you could easily replicate this and even this on your own. All right, so let's go and set up tiled so you can work with it very easily. So what I'm going to do is I'm simply going to remove the dungeon.json, house.json. I'm going to keep this as a reference for me because it's going to be a bit hard for me to replicate the exact same layout without having the actual finished map in front of my eyes. If you install tiled using the website I've shown you earlier on, you might have some issues. So the issue you're mainly going to have is basically that the font size is really too small. So to fix this issue, I haven't found anywhere how to fix it, but basically you go to the preferences section under the edit tab. So you go here, click on preferences, sorry. Now go to theme, and by default this is checked out. Use custom interface font. What you want is to check this and then increase the font as much as you need. I'm going to keep it at 18. You even can decide on the font itself, which font you want. I'm just going to keep the default and close it. All right, so now what you're going to do is here at the top, you do a new map. You click on that, and then for the orientation, it's going to be orthogonal. Basically, keep it as is. For the tiled layer format, CSV. And for the write down render order, so it starts from the right and then it goes down, I think. Well, basically, I didn't touch any of that. One thing you need to keep in mind is that you need to use a fixed map, not an infinite map. Otherwise, it's going to make drawing it in Kaboom.js much more complicated. Now here, I've selected 100 tiles by 100 tiles. And for each tile, it's going to be a width of 16 pixels and a height of 16 pixels. All right, I'm going to hit OK. And now you see the grid here. Now you need to add a new tile set. So basically, I'm just going to do just that. Now, to add this, you click on new tile set, and then you need to specify the source. And this is where you click on the browse button. So basically, this is the path. So this is my path, but your path is going to be different. Basically, it points to the assets folder inside of your project and the PNG. So either you use the browse feature here and you select it through the file explorer, or you just write the path manually here. So really, it's up to you. The tile width and tile height need to be 16 pixels as well. And then you click on OK. Now, by using the control key, you can increase, zoom in, zoom out. Control key plus the mouse wheel. All right, so we have everything we need, and you can see here untitled.tmx. This is not the format we want. So what you're going to do is basically going to click on Save As. So here I have in the file explorer, I have it set so that we have the desktop Zelda game, which is the folder where I put the code where I'm currently building the game, the assets folder that we created earlier on, and now the maps folder. This is where we're going to put our map. And here, instead of calling it untitled.tmg, it's going to be world.json. Now, having done this, it created a JSON file. Now for the if I look at the previous map I had here, I'm going to take inspiration and just tell you how to draw it. So here you have your layers at the top right corner. Here in the finished version, you can see I have a bunch of layers. So let's start with the first layer, which is the ground. So I'm going to call it ground. Now, what I'm going to do is I'm simply going to do a basic version of the map, really simple, just to show you how to use the program, how to create collision boxes. And then I'm just going to use my own stuff here. All right. Okay, so I created the ground layer. Now let's create a simple map. So if I go here, let's say I put it here, I can just draw it here. So I put a couple of tiles like that. You put here, depending on your assets. So oops, this should be here. So basically here, there isn't any miracles. You just draw it normally without, by just looking what makes sense. It's like the meme about drawing an owl. Just draw some circles and then draw the rest of the owl. So here it's basically the same thing. So you can have something like that, and I think maybe not. No. This should be appropriate. And then the tile here, which is going to be the water. And instead of having to draw the whole background, this is going to be performance intensive for Kaboom. So I just draw the tiles I need and then use a uniform background color within Kaboom to draw the background instead of doing it in the map editor. That's why if you go here, you can see that I only draw the water for the part with reflection here, rather than the whole thing. If I go back to the basic mockup map, you have it here. And now I'm going to, after having created the ground layer, you can right click, new layer, and then there are two types basically of layers you want. You want tile layers for basic tiles that you want to draw in. So those tiles don't have any like properties necessarily. You cannot have like individual properties, but the object layer is what you use for determining where the player will spawn, but also for the collisions. So let's create a first object layer, and the layer is going to be a the name what it is. The name for this layer, it's going to be the boundaries. So basically collisions. So I'm gonna call it boundaries. And what's useful here is that I can create, using the box, the rectangle, you select and then you can draw a first collision box. What's cool is that you can give a property to that specific box. Let's for now I don't see a reason to name it any, so let's just save with Control S. If I see here, you have just, if I select it using this is the selection tool. It's not very visible, but it's this when you are on an object layer. You can click on it and then you can see if there's any properties. Now there isn't in this. So let's go back to the basic map we're building. So we have here the collision, the first boundary. I'm going to create another one here and another one here, and finally a one here so that the player doesn't fall off from the cliff here. All right, I'm going to save all of this, and we just need to create another layer now. I'm going to create another object layer. I'm going to call it spawn points. So spawn points is the name. Is it true? Yeah, spawn points. And in this layer, you can use this. I don't know, this pin. I guess it's called a pin. Where, sorry, my mic is a bit below. Okay, all right. So it's called a pin, insert point. It's called an insert point in this program. So here I'm gonna create one, and I'm gonna give it a name. So the name I've given it is player. So this is how we're gonna know in the resulting JSON where is the player, where we're gonna spawn our player. So I'm gonna save this. Let's put one for the slimes as well. So let's put another after having saved, of course. Let's say we want a slime here. So here, just to make sure that everything is understood, the pin is here, but the character is actually going to be drawn from the top left corner. So, I mean, the sprite will actually be in this cell. Same thing for here. The slime is going to be in this section of the screen. All right, so now here, I'm going to call it, wait a minute. So yeah, I'm going to use the selection tool here. Remember, this is the selection tool. It's a bit of a weird icon, I think, but I guess it's the name. So I will select it, and I'm going to expand this. Why is it called spawn points? This is called player. Okay, I click on that. Click on that. All right. Now I click on name, and I'm going to call it slime. This is where the slime is going to spawn. So I think that's basically it. Now, one thing I want to showcase is the tree. So the way I did the tree is pretty interesting. So I think it's worth showing you how to do it. So I'm going to create another layer called vegetation. So here, right above ground, it's going to be a tile layer. It's going to be called vegetation. Now vegetation, we're going to put the bottom of the tree here in this layer, but we need to create another layer. And this layer is going to be called upmost. The reason I'm calling it upmost, and it's going to be also a tile layer, is because we want it to be above everything else, even the player. The reason for this is that the top of the tree, we want the player to go behind. So the player will go behind the tree, and it will give you the illusion that the player is behind the tree, because the top part of the tree is drawn on top of the player. Now, we need to add a collision to this. So in boundaries, we add a new rectangle here, and I click on that. I create my box. Now I can save. Now we have everything we need. We can go back to the code editor. And then later on, I'm just going to drag and drop this and the other maps. So I really want you to have just a basic understanding of how I did things. And then you can just open those maps as well, already made in tiled, and edit them and look at the various layers, objects being put, etc. For example, here you have 2 squares for the wall. You have named boundaries, so player dungeon, so that when the player collides with it, you can run some logic by looking at the name, etc. All right, now that this is done, let's go back to the code editor. And one thing I want to show you is that now in the assets maps, we should have the world.json. And I think it's interesting to just look at it, look at what the file is about. So what does this do? So the data, so we have let's collapse everything, and then let's go over one by one. So first of all, we have the height of the map, the width of the map. This isn't very important for us. We have what's really important for us is basically, I think the tile height is important, tile width is going to be important, but mostly it's this. It's the layers, how many layers we have. If I collapse this, collapse this, collapse this, and collapse this, and collapse this, we can see we have 1, 2, 3, 4, and then, oops, 5. 5 layers, and if we go back, 1, 2, 3, 4, 5, it corresponds. Now for the tile layers, like the upmost, I think this tile layer is going to be the ground. So in the array, the first element is the deepest layer, and then the layer on top, the layer on top, the layer on top, the layer on top. So for tile layers, where you just draw tiles, you get this data key, which contains an array of what? Of tiles, numbers, the frame, the specific frame in your tile set. So this 40, I guess, what does it correspond to is if I go to, I guess this, you click on that, you select, you can see that the ID of the tile is 40. It's basically the numbering. So how this numbering is done is basically it starts here at 0, 1, 2, 3. You can see at the top left corner while I'm selecting 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, etc., etc., etc. And then it switches to the next line, etc. This is how the numbering is done. So by simply knowing which tile is being used, we can basically know what to draw. So if I collapse this, you can see the name of the layer, which is the ground, and basically the width and height, etc. This isn't important. The most important part is this. Now for object layers, so this is another tile layer. So this is the vegetation, same thing, for where the bottom of the tree corresponds to 162. If I go back to tiled, select the bottom tree here, you can see 161. Maybe it's the topmost. Wait, what? It's 160. Oh yeah, because there is an offset, it seems. There is an offset because tiled, it uses 0 as the absence of the tile and not actually the first tile. So you have to add +1 to everything. So even though here it says that the ID is 0, actually for this tile it's going to be 1. So it's offsetted because 0 in the exported JSON corresponds to the absence of the tile, not the first tile. So this is something to keep in mind. It's going to be clear later on when we're going to deal with this issue. Hopefully, I don't forget. Okay, so we have the data here. Okay, so those layers are tile layers, and actually you can see the type here. But for object layers, so the boundaries, it's different. You don't have a data property with an array. You have instead an objects array, which for each contains an object with the height, the name, if there is any, but also the exact coordinates. And this is what we're going to use to draw those objects, which is the boundaries, the hitboxes. And if I scroll down and look at the spawn points, you can see that the name is player, so we can know this specific object corresponds to the data we need to know where to place our players, our player. We only have one. All right, now that we have the world.json and we've looked into the world.json file in depth, I think you have a better understanding of how tiled works with Kaboom.js. Now it's time to actually do the drawing, try drawing the map. Well, actually you have an idea of how it's possible to get all you need to draw the map in Kaboom. All right, so we have this async function called world. We need to import the map data. So we need a way to fetch this, to load this JSON file. Now there are recent features in JavaScript that would allow you to simply not have to use fetch call and really import it in the same way you would import a JS file. But for this tutorial, and I don't think it's supported outside of Chrome, so we can't use it. We want our game to work on all platforms, all browsers. And the two major ones, well, actually there's only one major browser vendor now. It's Chrome. Firefox is losing market share, unfortunately. I'm still using Firefox, but yeah, it's a losing battle, it seems. All right, and I'm not that attached to browsers anyway, but just wanted to discuss this a bit. All right, so we're going to need to load the map, and for that I'm just going to create a file at the root of the source folder in the same level as main.js. I'm going to call it utils.js. This is basically where we're going to put all the functions that don't fit anywhere else, and is basically a utility function. It's a utility to fetch the map, actually, not necessarily like draw it. So it's going to be used by all these different scenes. So I think it's a good thing to make it under the utils folder so it's fully reusable. All right, let's write some code here. And yep. So to load the map, we're just going to need, I'm just looking at, yep. We're going to export. Here, we're just going to export multiple things from this file. So we're not going to use default export. So I'm going to export an async function. So I'm going to export an async function. I'm going to call it fetch map data. Now this function, fetch map data, is going to take in the map path, which is a string that tells us where to look for the map. And we're simply going to return an await, so fetch call. So this might look strange, but bear with me, it's going to make sense in a moment. So we pass in the map path. We then call .json outside of it. So to explain this, sorry, I have to fix my mic, which my mic tripod, I guess, which keeps falling. All right, so what we need to do here, what we're going to do is, okay, so to explain this code, basically we use the fetch call to get, so the map path is basically the URL to the JSON file here, which can be found by just having a relative path, which is assets maps world.json. We use the fetch call here to get this. We need to await, so we need to wait for this fetch to be done before we proceed on with our code. And then once this is awaited, so once the result has come back in, we need to convert this in JSON, which is again is an operation that needs to be awaited again, because if you just return without the await, it's going to return a promise pending or something like that. So by just making sure that the JSON conversion is fully done, or it's made to JSON before returning, we'll make it like sure that when we get it back, it's actually some JSON. Now, the reason I'm using the parentheses is just I was too lazy to have it on 2 lines instead of 1. So this set to a variable in 1 line and then await that variable.json. All right, so we have this. We can just go back to our world. And in our world, it's where we're going to world theme. It's where we're going to just call it as, so I'm going to remove the rectangle. This is no longer needed at all. So I'm just going to do this and then remove it. And then I'm going to do const map data equal await. And then after that, I'm going to simply call fetch map data. Normally VS Code should show you this. It will import it, but it's not smart enough to know that we need a .js here because we're using JavaScript, native JavaScript modules. So we do this, and as for the actual path, it's going to be assets/map/world.json. Now that this is done, I think we're ready to actually draw. But before drawing anything, let's create a utility function that allows us to draw, maybe on top of that, the background to a specific color. So I'm going to call it export function colorize background so that we can draw the rest of the sea without having to use like various styles. So here we're just going to pass the context k instead of having to import it again and again. And finally, we're going to pass RGB values. So this is how we can define a color with red, green, and blue. There's a way to define it using hexadecimal, but for some reason when I'm using with K, like with the context, the non-global version of Kaboom, it doesn't work. So yeah. Okay, once we have this defined, we just simply add a k.add.k.rectangle. We create a rectangle that is going to be k.canvas canvas.width. So this is how, so the k object exposes the canvas, and you can then go search the width. You can do the same thing for the height by using k, which is the Kaboom context, get the canvas, and then get its height. Now you might be wondering why there's no way in Kaboom to just draw a background from a single color. There is, but the issue with that function that is provided by Kaboom is that it will colorize everything. So if I go back here, it will even color this part. We don't want this part to be colored. the same way here. We want it to respect the aspect ratio. I think this is a bug. It wasn't there before. So yeah, if you're a Kaboom maintainer and you're watching this, please fix it. Fix it if you have time, of course. It's not that big of a deal though, because there is this workaround. Anyway, so we create the rectangle, but now we need another thing. We need to pass in the k.color component. So Kaboom offers the color component, which takes in an RGB value. So R is going to be a number from 0 to 2 and 255. Same thing for here, and then same thing for here as well. All right, so now we only need one thing left. We need to use the fixed component, and this is going to come into handy when we're going to implement the camera, because we don't want this rectangle to move alongside the camera, to be affected by the camera viewport. We want it to always remain static regardless of the camera. So that's why you use the fixed component that is also offered by Kaboom. Yeah, anyway. All right, so we have this. We don't need to return anything because calling kadd just creates it, adds it to the canvas. So now what I'm going to do is I'm going to go back to the world.js, maybe right after having imported it. Or maybe you draw it first. It doesn't matter. It shouldn't matter. Colorize background. Now I'm passing the Kaboom context. Now for the specific colors, I don't remember them at the top of my head, so I need to go look it up quickly. Sorry. So it's 76, which those colors, those RGB values I'm mentioning right now corresponds to the bluish, the blue like sea-like color. The how do you say, the light blue color, yeah, used in the asset pack. The way I extracted those is by using Sprite, which is a pixel art editor software, and just looked at the RGB values using the color picker tool. All right, colorize background is called. Now, if I look at the result for that, you can see that we have a bluish, light blue, beautiful background. All right, now it's time to write the logic for the map. I think we're ready. So what I like to do is to create an object, a game object called map. So const map equal k.add. The reason I'm doing this is that in Kaboom.js, objects can have can have children that are assigned and then positioned relative to the parent object. So here I'm going to specify a position for the whole map. And this way, after having drawn the map, it's going to be very easy to move it where we need it. For now, let's do it 0. I think it's going to be fine with this. We don't need to move it elsewhere, but yeah. The other object I like to create is an entities object, which is going to contain references to the various entities we're going to draw in the scene. You're going to see why this is useful. So one player, so I'm going to put it to null intentionally. That's why you use null instead of undefined. Undefined is when it's not intentional. Null is when you want that you use it when you like, I want to make this null. It's intentional. That way, using it that way, you can know if it's an error on your part, you forgot to define something, or the programmer knew what he was doing. Now here for the slimes, we're going to draw many slimes, so we're just going to put that into an array. Now I noticed that if I go back to tiled, there's only one slime, so let's just add one. So spawn points, what's the name of this? The insert point tool. Let's put one here and use the same name, slime. It doesn't have to be unique. Save it with Control S, and let's go back to the editor. Now what we're going to do is we're going to get our layers. So as you probably remembered, in the world.json file, there is a layers property that contains all the layers. So if I go back, so I go back to the world.json, you can see that this is this key. We want this array. So what I'm going to do, I'm going to use the map data. So map data dot and what I'm going to do. So yeah, the reason we're using an await here is because this is asynchronous and we don't want to proceed on until this is fully resolved. So we have access to the layers, the object, the JSON object. All right, so now that this is done, we can just do layers.map.layers just to have a lighter syntax. And then we're going to iterate through those layers and draw them. So let me just fix that. So for const layer off. Now we're using the off loop, which allows you to iterate through an array. It's an easier version of the traditional for loop in JavaScript, where you have to define I and then another I++, etc. here. So you don't have to do that if you just want to simply iterate through an array. Now, here it's where it gets interesting. If the layer.name equal boundaries, we want to draw the boundaries. So I'm going to leave a to do here, and I'm just going to write a continue, because otherwise we want to continue with another if statement. This is how you get rid of else's statement. Most of the time you don't need to write an else. You can get away without doing it, either by returning early or using continue within a for loop, for example. It makes your code much easier to read at first glance. So that's why it's a good idea. I think I messed it up a bit. Never mind. We need another if statement within. Now, if the layer.name is a spawn point, though, so we're going to spawn points. It's called spawn points. We're going to, again, to do, and then continue. And then I think that's it. The tile are just going to be drawn here. The normal tile layer. The tile layers, instead of compared to the objects, the tile layers compared to the object layers does not need to be drawn any differently. Never mind, I said this wrong. So the tile layers can be just drawn by using the frame, etc. But for boundaries and spawn points, we need to have a custom logic to draw them. That while we can reuse the exact same logic for any tile layer. So here we're gonna to do draw tiles to do. All right, so let's first start by drawing the boundaries, the hitboxes basically, and then we'll do the same for the spawn points, and then, or maybe, you know what, let's draw first the tiles, because this is, I think, the most visual part first. Once this is going to be done, it's going to be like very gratifying to see something on the screen, your map. So let's go back to the utils folder. Again, we're going to create a function that is going to be reused by all scenes. So that's why it's in the utils.js. So this function is going to be called draw tiles. And the params it's going to take, it needs to take the context, the Kaboom context, because it's going to use methods from Kaboom. It needs to take the map object that we created earlier on in the world, so that we can add to it child game objects, the layer, each tile basically. We need the layer, the specific layer name. Not name, the layer is actually if I go here, you have layers, and then here, because in our for loop, layer, why do we need the layer? So we have, okay, so we have layer, because we need some data about the width and the height. So let's say each object here is named a layer, it's a layer, and for those, we have the width and the height, which is going to be useful, I think. All right, so in our utils, we need the map, the layer. Is there any other thing we need? We need the tile height and the tile width. Tile height, and then tile width. Be careful. Here I did not use capital letters like camel case, because I think that was due to the fact that in tiled itself, it uses lowercase tile height and tile width. And I thought when I was refactoring it, I just kept the same name convention here, so that you don't get, so I don't get confused. So that's why it's there. I think right now it might be safe to just disregard, but let's keep it that way for now, just to be sure. So here we're going to need within a variable named number of drawn tiles equal initially to 0. Now this will allow us to know when to move on to the next row. So we draw each tile in a row and then we move on to the next and to the next, etc. Now we're going to create a tile pause constant, which is going to be a vector2, and it's going to give us the current position of the tile. We're going to set the position. So this is basically the current tile position. So after having drawn one tile, this will be modified to change its values so that it's going to correspond to where we need to draw the other tile, etc. It might not make a lot of sense. You could have used a simple object with X and Y properties, but this is more convenient. It's shorter to write, and you basically have access to the same thing. So now that this is done, let's start with going through each of those tiles. So const tile of layer. So that's why the layer dot, I think it's going to be layer dot data, which is the property that is needed. If you remember in the world.json, this key. Basically, I think now that you could have just passed the data layer immediately instead of passing the layer object. But then again, we use the layer with the full layer with. Okay, I understand now, because we use this later on. That's why I did not just simply pass the data array to this draw tiles function. All right. Okay, so now within this for loop, if the number of drawn tiles modulo, I'm going to go over the modulo operator, layer.width equal 0. So basically what this line does, it allows us to know when we have finished drawing all the tiles of a given row. So the reason for this, the reason why this works is that we do the division. So number of drawn tiles divided by the width. If there is no remainder, I think, if there is no remainder, that means that the division was even. So we fully divided the number of drawn tiles by the layer width, which means that we have finished drawing the full row, because there is 100. Yeah, so there is 100 tiles in the. There's the width of the tile, the layer is 100. So by having this operation, you're making sure that you will only move on to the next line to draw, once the current line has been fully drawn. And that's why right below, I do tile pause. I set it, the x coordinate back to 0. That means I think a diagram is in order here. So here is, can I reset? Can I clear? Maybe if I do this and I remove that. So basically, if we were to draw a Cartesian diagram like that, and then let's say you have a bunch of tiles, I'm just gonna copy this. Whoops. Sorry for the poor. And then I'm just gonna copy all of those 3. Whoops. Gonna copy this like that. Okay, let's assume we have a full line. And then we just need to move on back here. So here, if I use we had 0. This is pretty thick in width, I guess. What? Okay, this is opacity, sorry. Is there a way to draw small, maybe? All right, that's perfect. All right, so here the x coordinate is 0 at the beginning, at this part. And then here, let's say it becomes, I don't know, 100. So once you know that you need to go back here, you will simply set back x to being 0. But your y is going to be increased by the tile size, so 16. So y is going to be plus 16. So I hope this was clear. Tile pos x equals 0. Tile pos y, though, we're going to add to it the tile, not to string, the tile width. The tile height. The tile height. Even though they're supposed to be the exact same thing in this sprite, in this tile set. And then otherwise, if we're not here, and here we cannot continue. So here we need basically to have a else statement. I could have, it's ironic, I was telling you don't need any else. But I think there's a way to write this logic without an else, but it's just that right now, I don't think we can. Maybe, let me think. Okay. I think we can actually. So if in the case, okay, so we want to do this. We want to increase the number of drawn tiles, plus plus. And then if the tile is equals 0, we want to continue. That means that we don't have a tile to draw. Remember, the 0 number in the array here means an absence of tile, not that we need to draw the 0th, the tile number 0. And here we have the map object. We use the add function to add to this existing game object children, and we use the k.sprite. And we're going to use the assets here. Now I need to explain where do you get this from. We haven't imported our assets into Kaboom yet, loaded our assets. But basically, we're going to load our assets, call it assets as the key, so we know which assets to use, and use as the second param to the sprite component that is offered by Kaboom, an object which can specify the frame property, which allows you to give the exact number of the frame you want to display on the sprite sheet. So tile -1, if you remember, we need to do this because of the fact it's strange that it's tile -1 because yeah, it is over incremented. So the way I did it, yeah, the reason for tile -1 is simply because we need to offset the fact that this tile can be 0. But what I find strange is if I go back to the here it's tile considered tiled 0. But if you subtract, it's going to be -1. Here it's going to be 1. It's going to become tiled 0. But that's because Kaboom itself considers the 0 as a proper tile. So Kaboom numbers their tile starting from 0, while tiled thinks that 0 is empty and the tiles start at 1. So that's why you need to subtract even for the 0th tile. So for example, in Kaboom, not in Kaboom, it should be simple to just understand this. If I look at the ground layer, you see 1 corresponds, okay, this corresponds to 41, 1 corresponds to the first tile. So this exactly is considered as 1, even in tiled, despite the fact that in the ID here is considered 0, which makes no sense. But because of this, you need to subtract 1 minus 1. It's going to be 0 because in Kaboom, when you load the sprite sheet, it starts numbering by 0. It starts with a 0 instead of 1. So that's why you need to do a tile minus 1. So just to recap, Kaboom.js, the way it loads assets, if you load a sprite sheet using the load sprite sheet load sprite function, I'm going to show in a moment, it will divide your tile set, if you do the proper things, into tiles, and those tiles start being numbered with the 0 index. So the topmost tile on your image, on your sprite sheet image, is 0, is numbered as 0 in Kaboom land. In tiled land, it's numbered as 1 in the exported JSON. So that's why you need to do a -1, because in tile, they consider the 0 as the absence of the tile, not the tile, the first tile. Hope this was clear, and let's move on. All right, so we have the sprite asset here. What we need as well is a positional component, k.pos, and we just pass in our vector too, which we created here and modified accordingly here. There's one statement that we need here, but I'm going to put it at the end in order to avoid having an else statement. And then k.offscreen. The off-screen component is from Kaboom, and basically it helps with performance. So when your tile is not visible in the camera, then it's going to be less computationally expensive, because Kaboom is going to do less calculations. For example, not taking into account the collisions, not rendering, not doing any calculations. So those are the 3 components you need. Now, like I said, in case this is wrong, we were basically forced to use an LC, because if we haven't drawn the full line, so it's not the time to move on to a new line, we still need to increment the x-axis to go to the next tile. So that's why we need an else, because otherwise, it would be repetitive to write another if statement, but with the contrary, it would be less good looking code. Now, yeah, it would be less good looking code. Yeah. So I think this is a rare case where I think you need to have the else here. If you in the comment have had time to think about it, maybe you could come up with a way to not have this else, but still keep the logic intact. So feel free to share that with me in the comments. That would be great. By the way, if you are enjoying the content I'm building, the tutorial, please feel free to subscribe for more. It helps out the channel, and even give a like, which would supposedly help the algorithm. So let's continue, and also comment, because commenting also supposedly helps with engagement. But yeah, let's just move on now. All right, let's go back to the world.js file, and here let's call our function that we just created, draw tiles. Now I call it, pass in k, pass in the map object we created here. Now the rest is the layer, so we have it here. And finally the tile width and tile height. Now what it might be repetitive here, so let me just look if we could improve this and not have to do that. Okay, so the tile width and the tile height and the tile width is for the overall map, not just the current layer. That's why we pass them separately. Map data, tile width. Here we go. Now let's look at the result and see if it draws anything. It didn't. JSON unexpected character at line 1 of column 1. Oh, come on. This error is horrible. Okay, I'm just gonna look into it. Oh, it's understood. This doesn't work because we haven't loaded the map yet, with the asset for it. So let's do just that. And I think this is going to make the error fix itself, but I'm not sure because if you've noticed, it was a JSON error, but maybe it will fix it. But let's first fix that. So basically for the assets, you could create a separate function for it, but I don't think it's that necessary for now. Let's just create a kload. Let's use the kload sprite. Use the asset's name. The first param is just a name you want to refer to this sprite, and this is going to be the sprite sheet. So in Kaboom.js, you use load sprite for everything. So for singular sprite, but also sprite sheets. Now you need to put path. So it's going to be slash dot slash. So a relative path is usually preferred. Here's because when you're going to try to host it, if you don't specify a dot, it might cause issues, but you can try it out. Either way, it should technically work, but you never know. Sometimes you have issues like that. I had some issues like that in the past. All right, so here, so the first param is the string, the name you want to use for that asset. The second param is the path towards that asset so that Kaboom can find it. Finally, the third one is the properties. And basically we want to use the slice x property, which is going to be 39, and slice y, which is going to be 31. Okay, this looks like magic numbers, but slice x tells us that there is 39 rows. I think it's rows. If I look it up real quick. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Let's go at the end. It's, yeah, because we start at 0. If you look at the ID, 0, and then 30, 30, 38. There's 38, 39 because 0 counts as 1. So we have 39 tiles that are, so we have 39 columns. So slice x tells you how many columns there is, even though it's called slice x. It's how many slices you want on the x-axis, basically. So on a given row, how many chops you want. And it's 39. And for slice y, it's 31. This basically allows Kaboom to know what each tile is. So basically, to do a drawing, so that things are understandable, but before doing a drawing, let's first test that this works actually. So refresh, we still have the JSON error. That's very strange. Everything seems to be correct. We have the correct asset path. So I'm gonna console.log the map data and see what I get. So if I go back to the browser tab, refresh, this doesn't even work. Why is that? I think, okay, let's go to main. We pass in the K. We have the world. If I go to world, you have K here. That's very strange. It should work, technically. Maybe I did it wrong. Assets, maps. Oh, I wrote map instead of maps. That's why. So that was a stupid mistake, but hey, it does happen. And you can see our map is actually fully drawn here. So that's a good place to start to stop here. Right before we do that, I'm going to remove the console.log and then draw the diagram just to explain to you how it works. So here again, I need to select all. No, not that. Here, select everything, remove them. Now let's have a grid. So slice X basically tells the, we have a line, yep. Tells Kaboom how to slice things. How to slicing. Ah, come on, this is tedious. You do this like that. Okay, so basically, here slice X would be 3 because you're making 3 slices. And That's why it's slice X. You're making 3 slices on this row. So you have this row, you have this single, like this row, you make 3 slice in that row. So that's why it's slice X equal 3. And slice Y would be 1. And then the more you add, slice Y, slice Y would be here 3. So now you have slice X 3, slice Y 3. You make 3 slices on the Y axis. That's why it's slice Y. And you make 3 slices on the X axis. That's why it's called slice X. Hope this was clear. Alright, so hopefully I'm going to see you in the next part of this tutorial to continue where we left off and draw start writing the logic for the player and the slime. Once we have everything, the drawing logic for the maps done, then I'm going to swap in the actual final maps I have made, and you can download them in the description. So yeah, thanks for watching.